This problem says, in the triangle shown above, if theta increases at a constant rate of 3 radians per minute, at what rate is x increasing in units per minute when x equals 3 units? A good first step is to list our givens. In the prompt it says if theta increases at a constant rate of 3 radians per minute, this means that the derivative of theta per time is 3 radians per minute. Also, it says when x equals 3 units, which means x equals 3 units. Also, it's important to know what we are trying to find. Since the prompt says at what rate is x increasing in units per minute, we can infer from this that we're trying to find the derivative of x per unit time. A nice formula that can relate all this together is sine theta is equal to x over 5, which we could see from the triangle. Next, we need to find the derivative because it will create an equation with d theta dt and dx dt, which we can solve. To find the derivative, we'll need to use the chain rule. The derivative of sine is cosine, and then we multiply this by d theta dt because this is part of the chain rule. This is equal to 1/5 dx dt because that's a derivative of x over 5. We can see that we almost have all the variables needed to find dx dt, but we're missing theta. Theta can be found if we remember that they gave us x equals 3. Since they gave us x equals 3, we can set up a triangle and use the sine expression to solve it. We get sine of theta equals 3 over 5, and then theta equals arcsine of 3 over 5. We can then plug this value back into the expression and substitute our givens in to get cosine of the value of arcsine of 3/5 times 3 equals 1/5 times dx dt. From this, we get 0.8 times 3 times 5 equals dx dt. This then gives us an answer of 12 for dx dt, which means we can circle E, and that's the answer.